In this lecture, we will be discussing linear equations that have no solution to them or an infinite number of solutions to them. All the equations we have solved so far have been conditional equations. A conditional equation is an equation that is true for some values of the variable and false for other values of the variable. That is, you get a numerical answer. That is not true for all equations. A contradiction is an equation that is false for every value of the variable. It has no solution. We identify the solution to be no solution when all variables fall out and you're left with a false statement. For example, you might be left with something like 10 equals 4. Definitely not true. An identity is an equation that is true for all of the permitted values of the variable. These equations have an infinite number of solutions. We identify our solution to be an infinite number of solutions when all the variables fall out and we're left with a true statement. -6 equals -6, for example. We don't know just by looking at an equation whether it's conditional, an identity, or a contradiction. So you just have to solve the equation as normal, following the steps that we've learned, and then if the variables fall out, we'll interpret our answer at the end. I'm going to start solving this equation as normal. I have parentheses. I'm going to distribute to eliminate those parentheses. 5 times 2 is 10. 5 times -x is -5x plus 8x. Distributing the 3, 3 times x is 3x. 3 times -6 minus 18. We have no fractions to eliminate. I move on to combining like terms. I have like terms on the left side of my equation that I can combine. That gives me 10 plus 3x equals 3x minus 18. We want to gather all of our variable terms on one side and our constant terms on the opposite side. I'm going to move the variable term with the smaller coefficient. In this case, they have the same coefficient, so I'm just going to make a choice. I'm going to choose to move my variable terms to the left side. That means I need to eliminate this positive 3x, so I'm going to subtract 3x from both sides. When I do that, the 3x's eliminate from the right side, but they also eliminate from the left side as well. And I'm left with the statement 10 equals -18. That is a false statement. And the interpretation of that is that we have no solution. This equation is a contradiction. I personally prefer to always move my variable terms first, but I know some people move their constant terms first. If you do that, it's possible that you would get a different false statement. You might get something like 28 equals 0 or 0 equals -28. These are still false statements, still gets us to the correct answer of no solution. In our next example, again, we need to distribute. I see this one has kind of that tricky distribution where it just has a negative in front of the parenthesis and not a number. Remember that when we don't see a number there, it's like an invisible 1. I'm going to be distributing -1 into the first parenthesis. -1 times 6x is a -6x. -1 times a +5, -5. On the right side, we'll distribute -2. -2 times 3x is -6x. -2 times 4, -8. We have like terms on each side of the equal sign to combine. These can be combined to give us -1 minus 6x. And on the right side, I can again combine my constant terms. That gives me -1 minus 6x. I need to move all of my variable terms to one side and all my constant terms to the opposite side. I'm going to move my variable terms first. The coefficients are the same, so I'm just going to make a choice. I'm going to choose to move my variable terms to the left side. To eliminate this minus 6x, I'm going to add 6x to both sides. The 6x falls out on the right, and it also falls out on the left. I'm left with the statement -1 is equal to -1. This is a true statement. So my interpretation of that is that we have an infinite number of solutions. This equation would be considered an identity. In our last example, we do have fractions in our equation. No parentheses to eliminate, but fractions to deal with. I'm going to do the same move that I did in our lecture where we solved the equations with fractions. I'm going to break this up into 4 fractions. I'm going to rewrite the left side as 5z over 5 plus 1 over 5 equals 2z over 2 minus 3 over 2. Now we want to eliminate the fractions. We eliminate the fractions in our equation by multiplying each term by the LCD. The LCD between 5, 5, 2, and 2 is 10. So each term I'm going to multiply by 10 over 1. The whole point of multiplying by this LCD is to eliminate the denominators. So we want to simplify the 10 over 1 with every denominator. 5 goes in here twice, 5 goes in here one time. We multiply straight across. That gives me 10z over 1, or just 10z. Next, 5 goes into 10 twice, 5 goes into 10 once. Multiplying straight across, I get 2 over 1, or just 2. In the next pair, 2 goes into 10 5 times, 2 goes into 2 one time. Multiplying straight across, I get 10z over 1, or just 10z. The last pair, 2 goes into 10 5 times, 2 goes into 10 one time. Multiplying straight across, we get 15 over 1, or just 15. Now we have an equation with no fractions in it. I need to get all my variable terms on one side, all my constant terms on the opposite side. The coefficient on my variable terms are the same, so I'm just going to make a choice. I'm going to choose to move my variable terms to the left side. To eliminate this positive 10z, I'm going to subtract 10z from both sides. When I do that, I see that the z's cancel out on both sides, leaving me with 2 is equal to -15. This is a false statement, which means that I have no solution. This equation was a contradiction.